is the basic idea. Now what we have to do is, first of all, turn it into a model. That's not that hard. So the model is just this. What my neuron is going to do is it's going to do a weighted combination of the inputs. Okay? Let's suppose, for example, that this was actually the retina, right? So this is the input. Each one of these inputs is a pixel. And then each one of them gets multiplied by a weight that corresponds to the strength of the synapse. And if that weighted sum exceeds a threshold, then I get 1 as the output, otherwise I get 0. So for example, if this neuron is trying to recognize a cat, if this is a cat, then hopefully what happens is that this weighted sum will be high enough that this will fire and the neuron will say, yes, this is a cat. Okay? Now, this is all easy. This goes back to the 1950s and Frank Rosenblatt and whatnot. The really hard and interesting and important question is, how do you train a whole network of these neurons, right? That's when things actually become very difficult. Because if you have a big network of neurons, like so here are my inputs. They go to one set of neurons, right? These are the functions that they compute, right? They're in purple here, and then those go to another layer and many layers until finally you get the output. Another question is, well, if the output is correct, right? So let's say this was a cat, and the network said that yes, it is a cat. Then life is good, right? Nothing needs to change, right? Why go fixing what ain't broke? But what happens if there was an error? Right? This should have been firing, but wasn't. And now the key question is like, what do I change in that whole big messy network to try to make it, give the right answer tomorrow? There is no obvious answer to this question because, think of one neuron, somewhere in the middle of the network. How is it responsible for the error at the output, right? The error at the output could have come from an infinitude of different places. This is called the credit assignment problem. Or maybe it should be called the blame assignment problem because it's deciding who's to blame for an error and therefore needs to change. And this is the problem that backpropagation solves. Right? And when people first came up with sort of like neural networks in the 60s, they didn't have this. It was when finally it was invented in the 80s by David Romerhart and others that things really took off. And the basic idea in backprop is actually quite intuitive, I think. It's the following. Well, let's think of the difference between my actual output and my desired output. Let me call that delta, right? This is the error. The output should have been 1, but it was 0.2, okay? So it needs to go up. Another question is like, what can I tweak, right, in these weights to make it go up, right? Well, a weight that is, thinking at this last layer, right? At that last layer, like the neurons with the highest weights are the ones most responsible for the result, right? And if this neuron is saying no, but the answer is yes, well, then its weight needs to go down because it's preventing it from firing. And if this one actually, if this one was saying yes, but this is not firing, then its weight needs to go up. Okay. So what I do is I compute the derivative of this error with respect to the weights in the last layer, and then with those, I now have an error signal coming from these neurons. It's like, oh, you should have been higher, right? You should have been higher in order to make this guy fire because you have a positive weight. You should have been lower because you have a negative weight and you're preventing it from firing. So now I know an error signal at the neurons at this layer. And I can keep doing the same thing all the way back to the input. And this is why it's called backpropagation, because what I'm doing is I'm propagating back the errors and then updating the weights, changing the weights in order to make that, that error as small as possible. Okay? So this is the backpropagation algorithm. It's what's at the heart of deep learning, and these days, this is used for just about everything on Earth, right? Very early on, people use it to do things like predict the stock market. These days, you use it, for search, use it for ad placement, use it for video recognition, use it for speech recognition. You use it for things like, simultaneous translation and whatnot. But, I think at least for the public, the best known instance of this is still Google's own, famous cat network.